Howdy, and welcome to today's Clear Measure webinar. I'm excited about this topic. It has so many good outcomes for so many teams and so many consequences if we don't have the right processes and practices in place to keep our software teams moving quickly. My name is Jeffrey Palermo, and I'm going to be your host for today. And I'm a chief architect here at Clear Measure, and also been a Microsoft MVP since 2006. And I've been for a long time been helping a number of clients over just, I'm going to reference kind of the past decade here at Clear Measure with software team productivity, or in a lot of cases a lack thereof. There's a macro shift that's happening in the business world, and many businesses have decided to have internal software development teams, and even non-tech companies. And over the last, 25 years, a lot of non-technical companies have outsourced the creation of software, and they've lost a lot of money. We've had the whole, overseas outsourcing thing that took a while to even get right for that model. But a lot of companies didn't get what they thought they were going to get. And they've shifted to operating software engineering teams in-house by hiring some of their own programmers. They consider custom software to be strategic for them, but they want more control over everything. They want more control by having their own employees in-house, becoming experts in their own business. And as a result, these companies, they've become frustrated, and they feel like they've lost control, because even though they have their own people, they're not getting the problem fixed in some cases. Some of them are frustrated that having that in-house team doesn't actually increase the pace of software delivery or solve every one of their problems. And so the goal of this webinar is to go over the common categories that consume the time and capacity of software teams everywhere. And my hope is that once you understand where all of your team's time is going, then you can make decisions to change and redirect the efforts to get the progress that you really want. And we have a really good crowd on our webinar today, and I know we have people who follow our webinar series. But if you're just getting acquainted with Clear Measure, we're a software architecture company that exists to empower software delivery everywhere. But our mission is to enable the in-house .NET teams to be self-sufficient, so that those teams, that you can establish quality, you can achieve the stability that you need in production, and you can increase the speed of delivery on a constant basis. And we do this through our Clear Measure way for effective software teams. And it's a collection of measures and principles and practices that, when put together, reliably increase a team's quality, stability, delivered, and speed, and make that team highly effective. And we really believe that when equipped and trained properly, every team can be successful. So you can ask more about that later. It's a drop-in process and methodology. It starts really simply with an assessment, and we go from there. Now, freebie, if interested, that this isn't specifically about it, but there's a lot of content in the book, .NET DevOps for Azure. It's a few years old at this point, but if it's interesting for you to have a free electronic copy of the book, then by all means, send me an email, or you can just put it in the chat. And Melanie is assisting me on the webinar, so she'll see that chat message and can take that request for an electronic copy of the book. And also, I host a podcast called the Azure DevOps Podcast, and you can pretty much search for Azure or for DevOps in any of the podcast directories, and this podcast will be kind of right there at the top of the list. And also, there's another video channel called Programming with Palermo, and it's in the podcast directories and also on YouTube. And has I get to teach, and on the Azure DevOps Podcast, I interview experts, and I really enjoy that. But on the Programming with Palermo video podcast, I get to actually do the hands-on teaching, so that's fun for me. And we'll keep kind of moving on. So let's get, we're going to get back into the content right after I push up this poll here. And we just want to kind of get to know who you are as an audience, what version of .NET that you're using, and what do you primarily do? Do you work on the software coding all day? Do you lead or help lead the software team, or are you outside of the actual software team and company management? And let us know that, along with who's using .NET Framework 4, 3.5, and who's using .NET Core or .NET 5, 6, or 7. And of course, .NET 8 is coming out in November. So every year we're getting a new Visual Studio, we're getting a new .NET Framework, and whatnot. So kind of leave that up for a second, but there's a lot of software teams that we see here at ClearMeasure as we help these companies build effective software teams in-house. We see that those teams, when they come and meet us, are not moving at the pace that their companies would like. And one of the ClearMeasure Way tools is a self-assessment. It's easy to find on the ClearMeasure website. And one of the subjective questions included is, are you happy with the pace of delivery of your software team? And most respondents, when they start with us, they're not able to answer yes. And so we're going to talk about that. That is the topic of today's today's webinar. So let me just move on to the next slide and kind of move along. Got some pretty pictures, and I kind of follow the Baja 1000 race, so I like that stuff. But there's a lot of businesses that, again, have decided to have those internal software development teams. And for tech companies, they have to. They absolutely have to. It's of strategic importance. And for others, it's kind of a judgment call. When you're operating the team in-house, they consider it to be strategic, and they want to have more control, but they find that they don't have a lot of visibility into where the time is going. And as we go through the common categories of time sucks, effectively, that sap the capacity of software teams, and my hope again is that as you understand where your team's time is going, you can go fast. All right. So there's 5 categories overall for where a software team's time is going. You got working on new software, you've got diagnosing or fixing or reworking past work that we thought was done. Number 3, you've got diagnosing or fixing the software as it runs in a production environment. Number 4, you got administrative non-software work. And then number 5, you got time off. So I'm just going to go through those one at a time. Working on the new software. This is where we want to maximize the effort and spend all of our time. We want all of our team to be working on new software. And this is where we build new features, we make important changes, we enhance features so that they work even better. This is what our internal and external customers are asking us for. They think that our team spends all of its time in this category, but in reality, some teams struggle to get even time to work in this category. This first category, it includes everything in the software development lifecycle, from talking about the vision for a new feature. Well, that's part of this category. Doing architectural prototypes for options for new changes. Well, that's in this category. Even routine maintenance on our software. Well, that's in this category. And yes, even boring things. Renewing a security certificate. That's also in this category. It's expected important work. It's work that we can see. It's work that we can forecast. It's work that needs to get done. This is the type of work that software engineers and architects sign up for. The other categories are work that the team has to do just to get back to working in this first category, which is what they really want to do and what all the customers want to do. The second category, as we dive in, diagnosing or fixing or reworking the past work that we thought was done. This is the first type of waste work. This is where we realize that something is broken. Something we thought was done is not actually done. Software that was supposed to work in a certain way, it doesn't. Or maybe something is missing. Or we're surprised that now that thousands of users use our software, our computing performance in some of these areas is now terrible. We didn't count on some database tables growing to the size that they've grown to, or the distribution of the data being like it is. And we're spending time figuring out why we have a problem. And then once we've reproduced the problem, we're trying to redesign something in the software so that we fix the problem. We lament that we didn't catch this problem earlier, or maybe we just made a change and something else in a seemingly unrelated part of the software just broke. We don't quite understand how they could possibly be related. Okay. Now, the third category, diagnosing or fixing software as it runs in production, is all of our production stuff, all about production issues. No feature bugs or build breaks or bug reports from UAT testing. This category is for all the time spent investigating an issue in production. Let's say a user submits a trouble ticket, or a piece of our software system goes down and has to be restarted, or a user has a question that was escalated somehow to second level support and it comes to the software team. And not only do we have to spend time to figure out if it's just user education that accidentally made it to the software team's queue in the ticket system, but we have to spend time to learn about the part of the issue that may be a genuine defect, even if 99% of it is not. And part of this category of work is also properly equipping our own company's customer support team with a better knowledge base so that they can handle more basic customer issues. Not all of them should be coming to the software team. Also, part of this category is alerts that the production environment is sending to the ticket queue. And also another part is when, say, executives or salesmen call for special support because they want to do a customer or investor demo and they need some extra data pushed into a production or a test environment so that they can do the demo. In general, this is the category for any time spent because the software is in production being used by real people. All right. Fourth category is that administrative non-software work. And this category is probably the easiest to describe because every department has it. You got your company picnics, staff meetings, department all hands, potlucks, generalized training. You even got checking email or installing software or rebooting computers because a bunch of updates forcibly installed themselves and all kinds of other stuff that distract us. It's time spent at work, but it's not necessarily related to the software team's type of work at all. And then finally got time off. This will always be there, and it's not a category for optimization. We don't find that developers across all our clients are taking too much time off. We actually find the opposite, that they are so invested and so dedicated that they work overtime, and they're even working on weekends. But even with working a lot of overtime, if we don't have the right process, then the team as a whole isn't delivering at the pace the business needs, even while everybody is working themselves to the bone. But time off needs to be there. And of course, it should be a part of our forecasts, especially around Christmas and other seasons that generally affect the working capacity of our team. Now, the clear measure way for effective software teams encourages us to sequence the establishment of quality first as a priority, then the achievement of stability in production, and then a focus on increasing the speed of delivery. We have to play some defense before we can focus on offense. If we start right out of the gate, focusing on speed, I got to go fast. If we haven't established the right level of quality and created a high baseline, if we haven't achieved just basic good stability in production, then we're going to be on the losing end of the capacity equation. Our team's capacity is going to constantly be stolen away from us. And if we do that, well, it's the bed we made, but we have to sleep in it. Now, the good news is that it's our bed and we can change the sheets. And there's straightforward known practices for establishing quality, known practices for achieving stability, and we just have to put them in place. So let's break this down. Why might my team be moving slow? Well, let's consider your objective or target to be your destination. And maybe you're launching a brand new software capability in an existing system, or maybe you're making some changes with the goal of increasing your per order size up, $2 more, or maybe you're making changes that you think will lower your Azure bill, because everybody knows their Azure or AWS bill is too high. But either way, you have an objective. And your objective is the destination on the map. So get that kind of image in your head. It's the destination on the map. But you also know, or you have to know where you are, and then chart a course to your destination. The course that you chart is kind of like your turn-by-turn directions on a roadmap. Your roadmap is going to contain development items. It's going to contain new features, changes to existing features, all those things. And you identify all of these segments that you need to build with the expectation that you're going to arrive at your destination. Well, here's the problem. We, as an industry, we don't have a good track record of plotting roadmaps for software. Actually, with all the studies and surveys that have gone around and the Puppet Labs, state of DevOps and a lot of other, we basically have a 33% batting average. In baseball, what is that? 330 batting average. The Scrum methodology, the product owner theory, it really hasn't played out. There's no company that has such a person that can fulfill Scrum's definition of this product owner, which has gotten a lot of play over the last decade and a half. There's no such person that can prioritize the right features and changes, that will plot the right course and actually be right about it. And the batting average for even the teams that employ a product owner is about 33%. Whereas, a third of the time, they're right. Another third of the time, a feature is analyzed, designed, built, tested, put into production. You enhance the monitoring for that new feature, and it makes no difference at all getting you closer to your business objective. And then the last third of the time, you build that new feature, you make a change, you put it in production, and it actually hurts you. It actually does exactly the opposite. You need to hurry and back it out because it's harming you. So, just having a person who is anointed with the designation, you will figure out the right features to build. Well, the actual batting average is 33%. So, we obviously need the right course to the destination, but we've learned as an industry that there's no magical, wise sage of a person that is just somehow going to know what to do and be right all the time. But we need the right course. So what do? We iterate. We have to learn the course. We have to take our bearings, take a step forward, take our bearings again, and then plot the next leg of the course. We aren't good at plotting the entire course at the start of the journey. Just like if you're going to go through the Amazon rainforest, you've never been through that part of the rainforest before. You need to go exactly west, but you need to go around a lot of obstacles and generally take your bearings and see if you're going on the right course. The only way to actually plot the course and be right about it is to have somebody that's actually gone through that same part of the rainforest before and has gone to your destination. And just like in a software team, if you have people on a software team that have built that same type of software before for the same type of customers in the same industry, well, yeah, you got a leg up on it. You got people who literally have been there, done that. They're a rainforest or jungle guide, and they've been through that jungle, and they can take you through the jungle. That's awesome. But for so many organizations, we're building a type of software based on hypotheses and objectives. We're not rebuilding a type of system that we've done before, okay? And so we want to minimize, that's just the reality we need to understand if we're in that situation, because we're going to end up building 2/3 of our time spent building things are going to be things that actually don't bring us closer to the objective if we're in that situation. So overall, we want to minimize the distance to our destination. We don't want to zigzag all over the place and make a long route. We want to minimize the work, and we don't actually know a lot of times how to minimize the work at the start. We only have a guess, and so we need to iterate very frequently and take our bearings so that we stay on course as much as possible. Next, after that, okay, yes, we need to maximize speed. If we're sitting around taking breaks all the time, or if we're just going really slow through the rainforest, that's not going to help. If we're on that good course, we need to be moving at a reasonable pace. Now, let's talk about minimizing work. The best way to minimize the work is to stay on track and course correct, like I mentioned. Airlines run this this way all the time. They put on autopilot. Autopilot is constantly making minute adjustments, but without autopilot, as soon as you take off from the airport, you're off course, and they have to correct, and then the wind blows, and then they're off course, and they have to look at the compass and redirect. So it's normal for airline pilots. A mistake teams make is, and this is huge, accepting work into the development queue, into the software team that varies in size or varies in the amount of work. Using estimation techniques, that also hasn't really panned out for our industry. We've got planning poker, we've got estimating by Fibonacci numbers. Those haven't actually worked in practice. Now, there are teams that use planning poker and use Fibonacci numbers and have reported success. But where those teams have found success is by eliminating the upper 2/3 of the boundaries and basically not accepting anything that's estimated at more than just the small single-digit numbers. Okay, and effectively they're doing the same thing. They're only accepting work into the queue that are small. Okay, which kind of fits the main point of this, but we can only estimate things that we have clear line of sight to. What has worked is using Kanban's work in process limit and standardizing the work size. And by the way, this works in factories as well. This works in assembly line work also, where the size and type of the work is standardized to be very similar. What also has worked is not pushing work into the development team that is more than one man day of effort. Think about it. Ahead of your coding stage, changes and new features need to be broken up into units of development work no bigger than a day of effort. Now, don't immediately think of an objection. Oh, well, some things just can't get done in a day. Okay, that is true. However, when planning, the ideal that we recommend is to break up the units of work so that when your team looks at every item, they believe that each of those items can be done in a day. Now, could something surprise you and it drift over into a second day? Yes, but that's a very different situation than when the team looks at items, they're thinking, all right, that one's going to take 4 days, or that one's going to take 7 days, or that one's going to take 2 weeks. And then you work on it for 2 weeks, and then that kind of you learn something new, and that 2 weeks drifts into 4 weeks. That's very different from looking at something and say, I can get that done in a day, and then it drifts into 2, because you have more iterations, you have more cycle times to course correct and learn about it. And when I say 1 day, think of this example. You have a new feature that's a new screen in your application, and let's just take a Blazor WebAssembly application. All right, here's a feature. Well, let's design it. How are we going to do it? We have known design patterns. Of course, if you don't have known design patterns, you do a little bit of time boxed architectural work and figure out a proof of concept. But you've built screens before. Okay, we're gonna need the Blazor component. Boom, that's one item. We're gonna need maybe a new database table. That's another one. Oh, we're gonna need a web service to get data back and forth. Okay, that's another one. We're gonna need a we're going to need some type of command or query object to do the logic of this. That's another one. So immediately you've broken down 3, 4, 5 things, and each of them is probably well understood. And each of them, you look at it and say, oh, we've done those things before. We built a screen before. We've done data access with SQL Server and Entity Framework before. Or we've done a web service before. And each of those items, you're like, yeah, none of those should take more than a day to get done. In fact, I would posit that you do it that way. Some of those you're like, oh yeah, that one's going to be done before lunch. But by just by breaking it down and enumerating all of the independent items, well, now you've got things that are able to be developed in less than a day. And if you don't have line of sight for being able to clearly see what needs to be developed, you're not ready to put hands on the keyboard. Recognize that this thing is still being designed. If you have unanswered questions for how you would go about programming it, well, then we still have unanswered design questions, and we're not ready for coding. We're not ready to dispatch it to someone who's going to write the code for it, implement it. All right. All right. So splitting up the work, it absolutely ensures that we understand it and that we've decided on those design elements. Now, once coding begins on something, we do not want to have to stop because of a gap in understanding. We need to keep up the pace, or else our team moves really slowly. Like I mentioned about, you have to keep walking through the jungle in order to keep up the pace. If we're constantly stopping because our shoes aren't tied and their shoes are falling off, or our backpack is all the things are falling out of the backpack, whatever the reason we have to stop, our pace is going to really, really suffer. So we need to keep up the pace. Starting coding on something that's not ready and then having to stop and have a meeting or stop and have a conversation, it means that we didn't finish the design on this item. Okay. So we don't want the stop, start. And something's going to run long, by the way. Yeah, it's better to have those 1-day items run into 2 days, allowing us that opportunity to stop the bleeding rather than it happen on larger items. Because if we have a 1-day item, then maybe halfway through the day we did learn something new and realize, oh shoot, yeah, we said that we were going to integrate with this third-party system, assuming that it was just like the other one, but this integration is very different. We need to rethink this. Okay, that's better to know it a few hours in than 1 week in. Okay. All right. Now, we also want to minimize work through simple and well-known designs and design patterns. And we also want to do things that, Capers-Jones publishes in his research about high quality and high speed software, like reusing defect-free components. That's in the top 5 in building quality software anyway, but it also makes delivering software faster, is reusing components that you don't have to develop from scratch. That's a whole lot of code that you don't have to design, build, test, and debug. If you can use open source and commercial components and libraries and tools and other systems that you can integrate with, then that's going to really make your team go faster, minimize the amount of work they actually have to do to accomplish the business objectives. And finally, as a part of this category, refactoring is our friend, keeping the code base easy to understand. The point of refactoring is to make a change and then have the resulting code be as if this new feature were planned to be that way all along. That's the point of refactoring. And it's not like a parking garage where we say, oh, if I want to add another layer onto the parking garage, I need to redo this foundation because it wasn't, spec to carry all that load. In software, all of our materials are virtual and we're not constrained to physics like we are when building a parking garage. And so we can, there's refactoring patterns where we can add more structural support without losing the rest of the parking garage or having to bulldoze it and start over. So that's good. Refactoring is our friend. All right. So now we're down to the question, what saps our speed? Let's say that we're actually focusing the time on the software at hand and not fixing things, not fixing tons of bugs all the time, not fixing production all the time. What else saps our speed? How do we keep our pace up? Well, there's two components of speed. There's productivity per person, and then there's utilization. Okay, so we kind of talked about utilization, but productivity per person is a measure of how many items one person can get done in a day and in a week. And for that, we need the proper skills, we need good automation, and we need excellent tools. We see too many teams with generalist developers who are given every assignment under the sun. And a lot of times they're called full stack developers, which means, hey, I'm a developer of anything. You can have me develop just anything because I'm a full stack. And what they mean is, no, I'm a full stack of the stuff that I'm used to using. But if we don't understand that, leaders and executives of a company see that and say, oh, I have a developer. That developer can do anything, any assignment under the sun. Well, developers are used to learning new things, and developers are typically pretty smart and analytical and motivated, and they're not typically good at judging when a certain path is going to be a black hole of, I'm stuck. And by the way, I've been a programmer since 1997. And so all the stuff I'm saying, I'm also saying about me and things that I've done over the decades and things that I've learned, okay? Because I am a programmer. We all get stuck, okay? But if someone has never done a type of work before, then start with training. Train first, then do the work. It's the same thinking of sharpening the axe before cutting down the tree. Swinging a dull axe at a tree 100 times may chop down the tree, but it's 10 times more effort than using a sharp axe, and it takes 10 times as long. All right. Automation is also important. In today's world, there's no excuse to have your team doing manual builds, copying files to servers for deployments, configuring settings by hand, typing or remoting into a server, or going to the portal of cloud services, or even individually checking individual logs of services or different servers. Everything should be automated. The builds, the testing, the deployments, the monitoring, all of it should be automated. As an industry, we know how to do that now in 2023. If you go back to 2003, 2005, yeah, you could say that the industry was still learning what the best way to do some of this stuff was. But now in 2023, we know how to do all of it. There's great products for all of it. It requires no more invention anymore. It just requires putting the tools in place. Okay. So automate all of that process stuff. All right, finally, let's talk about tools. If your team doesn't have the best tools, they won't go fast. Just like a race car, if you want speed, you need the equipment. Some of the basics, it's a super fast computer, and also a good network, ReSharper and other Visual Studio productivity add-ins. There's so many great tools out there that I'm not going to give an exhaustive list, but if your developers are just using Visual Studio and that's it, then you're tying one of their hands behind their back. All right. There's so many tools out there that make everyone productive. Okay. And more tools are constantly coming on the market. All right. Finally, let's circle back to utilization. And this is a huge problem for why a team isn't moving fast enough. It's that the team isn't working very much. The utilization is low. I'm not saying that they're not at work. The team isn't working very much on what's important. They may be working those 100-hour weeks, but if all the time is going to diagnosing bugs or production issues, then very little time is actually going to new features and valuable changes. So from a cost perspective, your software is ultra expensive to maintain, and very little budget is actually going to new development because it's all going to maintenance. And so for the people who are financially minded, or the folks who are in company management, if you're in the finance area, you might say, man, we're spending a lot of time on maintenance, or you might not even be tracking it that way. You may be You may be, tracking the salaries of the team and saying, oh, this is the cost of our software team, but maybe you don't have any visibility into how much of that line item in your finances is actually going to R&D and how much is going to maintenance. Okay. That's important to know. And so there's two things that you can do to fix this problem if you find your team going slower than you want them to. And fix the problem of utilization specifically. First is prevent the defects. Second is prevent production issues. And I say prevent, I don't say fix quickly. Obviously, when they happen, we want to fix them quickly, but we want to prevent. Okay. Just like I don't want to get sick health-wise. I want to prevent sickness. How? By doing things that are healthy. Same thing in software. We prevent defects by healthy software engineering hygiene. We prevent production issues by healthy DevOps practices, DevOps hygiene. And by the way, I don't want to run long on this, time is limited, but we have plenty of other content around practices and tools to use for preventing defects and preventing production issues. But the first step is realizing which one is your nemesis. Is your system always having trouble? Do business disruptions sabotage your day? Or are defects a big problem for you? Do you have a feature backlog as well as a bug backlog? Two different lists of work. Are you having to prioritize bugs because you have so many? The biggest problem and reason some teams can't move fast is because they don't have much time left to write new code after handling all the problems their previous codes caused them. So a mindset change is needed first. Establishing quality has to be first, then achieving stability in production. Then, once you have your team's capacity back, you can work on speed. When only a fraction of your team is working on new code, thinking about speed isn't going to get you much. You have to start with establishing quality. And if you're in a particular code base or system that doesn't have your safety net, doesn't have multiple levels of automated test suites that capture problems, then you've got a lot of work to do on establishing quality. There's a lot of practices. The testing pyramid is a good mindset of baseline small scope tests. And then the next layer of testing, and then at the top, you have your full system acceptance testing that run on a fully deployed instance of your software. But you need your entire safety net, and test is one piece. Multiple layers of static code analysis is another part of establishing quality. We talk a lot about quality, but you have to have the mindset of getting to a high baseline of quality first, then a high baseline of stability in production, and then you can work on speed and getting your team faster. All right. Now, I talked about plenty of tools and that'll help you increase quality and stability and work on speed. These are just some teasers that I've thrown out. Reach out if we can help with any of them. It's far too much to cover everything in this short webinar, but if what I'm showing you here on the screen is a highly shrunken technical blueprint for the structure and flow of a DevOps pipeline that are implemented with some common services like Azure DevOps and Octopus Deploy. It has continuous integration. It has a 3-tier deployment pipeline. I'd like each of you to have this. This is only the first top third of the DevOps poster. It's meant to be printed on 2-foot by 3-foot poster board. You can take it to a print shop. But if you'd like the high resolution PDF of this, then you can send me an email or just ask for it in the chat, and we can get it for you. But this is the process. This is the structure that you need to have in place for your software team, and it gives you the foundational pieces for your quality control checks, so that you can increase the quality there. Also, there's some specific ways that we recommend structuring your Git repositories and the relationship between multiple Git repositories and larger systems. When you have a system that's broken down into microservices and multiple applications, this structure in Git is really important to establishing quality at the system structure level. And it is at the beginning of the DevOps pipeline. It's kind of like where everything flows from. Everything flows from the code repository. So if you make your mistakes here, then you're going to be fighting them all the way down the process. Okay. We also have guidance for individual Visual Studio solution structures. There are specific ways to handle references between projects and the allocation of library dependencies among your projects so that you have proper separation of concerns and dependency management. Again, if you make mistakes here, you're going to be fighting them downstream and maybe misunderstanding the causes. We also have guidance on private builds and continuous integration builds. Those have to be done in a certain way to bring the value, to create that really good safety net. We have guidance on that as well. And as we kind of close up, we've got tons of success stories. We've got plenty of testimonials on our websites. We like to see our clients with a fully empowered and effective software team. And we want you to be a world-class team and be awesome at delivering software. And the best way to start, if we can help, is with our 30-point inspection. We want you to rest well, knowing that you're on the right path. And so we have 7 different areas that we inspect coming into a new team: infrastructure, source control, private build, integration build, release management, deployments, and runtime observability. And so if you know that, hey, you know what, we don't know what we don't know, and I have a suspicion that we're missing some stuff. We're not getting the quality that we need to. We have production issues. The team's not going as fast as they should be, but I'm not quite sure what to change in order to get where we need to be. Then this is how we can start with you and start helping, is with our 30-point inspection. Come in and spend some time with your team and with leadership of your team, getting to know the nature of it and looking at everything under the covers and inspecting everything relevant to this to help you achieve those ends. So give us a call or send us an email if we can help with a 30-point inspection and give you clear recommendations on how to increase that quality and stability, and then ultimately speed of delivery. So I want to thank everybody for coming to the webinar. And at this point, if I think there were some questions that came through that I was able to work into the content, and a lot of requests for the poster, but I want to be respectful of anybody's time. And if you have to go, then that's completely fine. I'll leave this slide up. But if there are any questions that I hadn't answered, then I invite you just to hang out for a bit, and you can put those in the Q&A box in the Zoom software, and I'd be happy to answer those. Here's a question that came through. On this inspection, you have private build and integration build. What's the difference? All right, so that's a good question. Continuous integration, way back in 2006, there was the book from Addison Wesley Press about continuous integration. And in that book, continuous integration was defined as 3 stages. The first stage is called the commit stage. That happens completely on developer's workstation. The second stage was the integration stage. That happens on a team shared server of some sort, where changes from multiple team members are integrated, and then a new build of the software is created. And then the third stage was the first deployment. And that was deploying the results of your integration build to some type of environment to verify the integration build. Okay. So continuous integration has 3 stages. The first stage is your commit stage. And so the private build is a tool that helps you execute that first stage. And it gives you the build script that cleans up artifacts just to get ready. Every build is in fact a test. So every build is responsible for its own environmental setup, but it runs a build, compiles your code, then runs as many tests as can be run on a developer workstation. Your unit tests, your component level integration tests, and whatever checks you can pack into reasonably into running on the private workstation. It also does environment setup, like creating a local version of your SQL Server database so that your component level integration tests that run SQL queries actually have a database to run against. And that's usually in PowerShell, just simple shell scripting to do that. And that answers the question for you: with the changes that I just made on my branch, am I ready to commit my code, or did I just break something? And do I have a unstable software system now and there's no point in committing? Because if the build finishes, I know that I'm ready to commit and push my code up to my feature branch, and I can do that. And then the actual act of committing and pushing it to your Git repository, that finishes that first stage of continuous integration. And then the integration build, well, it uses the same script. Mechanically, it uses the same PowerShell script to do the same types of things, but it exists for a different purpose. It doesn't answer the question, did you break something? It answers the question, with all the changes from multiple different places and multiple branches merged into a single branch, with the combination of changes coming in from multiple places, do we still have a stable software build, or did that combination of changes just break something? Then if that particular part passes, then the integration build finishes up by packaging the different deployable components of the application and creating those deployable packages, whether they be NuGet packages or zip files, and it stamps them with the name of the application and the build number, and then archives them in whatever package manager you're using, whether it be Azure Artifacts or whether you're pushing it to Octopus Deploy or putting it somewhere in a directory of zip files. So that's the difference between the private build and the integration build. Both are hugely important. And we see teams a lot of the times they'll configure Azure pipelines or GitHub Actions, and they trigger on a change to the master branch in Git, and all they do is run .NET.exe build, which is effectively just a compile, compile and linking of libraries. And when that's the only check you have, you're not even running tests. You don't have a quick feedback cycle. Now, let's say that you did have test libraries and you ran them there, but you didn't run them locally. Well, when you break something, you don't find out immediately locally. You've got to wait until you push it and share it and do it on the shared server. And now you've got a broken build. Now you've got to roll back source control, and it's a lot slower development loop. Okay, so that's really important. All right, I think we've got all those questions answered. Okay, awesome. Well, thank you for that. And for the other people who submitted questions while I was talking, I was kind of able to work that in as I was going through the content. So I appreciate that. Thank you all for your time. And I hope you have a really, really great Thursday, and God bless.